Hello, good morning. I'm Schotten. I've worked already more than 20 years in the Geothermal, so I have already a lot of experience. I did already 20 years ago. I installed already the first pump in Geothermal. Yes, and yesterday we heard a lot of information about drilling, about seismic, about power plants, but how we get the water to the surface, you need a pump. And yeah, luckily we supply the pumps. And the pumps will also improve your power plant. Our geothermal pumps can go up to 200 cc water with no problems. We use it for swimming pool, glass houses, and of course our power plant. What you see also, we use pumps when the well is depleting, when the water level drops or the pressure drops, then it goes with pumps. We use it for municipal, for heating up houses, for industry we use it, and also for agriculture. What I've seen in the Netherlands with glass houses, the water is used for heating up the glass houses, and the rest heating is used for swimming pools. Yeah, power generation we can use with our pumps, and our pumps we can also use for the injection. Yeah, what you see here is the installation. You see on top, you see the PSD step-up transformer on top. You see junction box, and then when you go down, you see the pump, the seal section, the motor, and the gauge. The gauge is measuring the pressure, the intake pressure, the discharge pressure, the vibration, the discharge pressure, and yeah, the motor and the cable. The cable is just a plug-in, like a socket. So you plug in the cable goes to surface, and the cable goes to the junction box, which is the transformer, and the VSD. With the VSD, we control the speed of the pump, you can control the pressure. Yeah, that's more or less the controlling of your reservoir. The water comes in your inlet for your preparation. The water is coming, passing the ESP, it's cooling your ESP, goes in the intake, and then the pump takes the water to the surface. What is quite important is that you need control. So the pressure needs to be read, so we can do all kind of safety settings in the VSD, like if the well is dropping, or motor vibration, or the amperage goes up. All the safety systems are in the system. So our special VSD designed for this application. Choosing the wrong ESP has a lot of consequences. So if you don't have all the data, or you have the wrong calculation, yeah, then you will destroy the pump. It will also running out of its operating window. And also, if it is running out of its operating, your efficiency comes down, and you lose a lot of electricity. If you choose the wrong motor and your ESP or your well is too hot, then the motor will burn. If your system is too big or your system is too long and your well is deviated, then it will not go to the well. So all this kind of information need to be recalculated in the project. if you look to the competition, you have ESP or GSP for line shaft and the well self-flow. Yeah, with GSP you generate much more revenue because your power plant you can run quite more efficiency, so you can take out the maximum efficiency up for your power plant. Your performance goes up. Your stability, because you can control your efficiency from your power plant. Reliability is quite high, no noise. What I've seen in Iceland is that the line shaft pumps, what they used in the past, make a lot of noise. And our system is on the ground, so it makes no noise. Pressure flexibility, you can control it with your frequency controller. And we have scale propensity with injection lines, we can control the scale. Our permanent magnet motors, what we promote compared to the induction motors. With permanent magnet motors, we can reduce the cost of electricity up to 25%, even in some cases up to 30%. That's a little bit depending on what kind of pump and where it is operating. But with our permanent magnet motor also, the heat rise from permanent magnet motor is less because they use less amperage. I will explain later on why and how. And when it is running less hot, your lifetime goes also up. Another advantage is because the motor is generating less heat, also you have less scale. Scale is also related to heat. So all the calculations will reduce the total power block cost. Bit of technology. This is a picture from Iceland, where we installed an high efficiency pump. I think we installed in 2019 and still running. We used a splice with 3 cables, so we spliced the cable already in factory. So when we go to location, all we need to install, we don't have to do a splice or something like that. It will take 6 hours. We installed a very speed splice. And it's quite successful installation there. Now a little bit technique. You see that the fluid is coming in, the fluid is coming to your impeller and it goes up to the surface. How much stages, that's depending how much height we need to, I call it total dynamic head, what we need to fill up. That's depending on the pressure you have to need to service or how much drawdown you have. So the drawdown is you can calculate about the PI, your productivity PX. Here a little bit the different stages we have. You have a pancake, you have a centrifugal vortex, and another centrifugal vortex, and a mixed flow. The difference is the form of the stage, but also the mixed flow, what we're using in the geothermal, and also a little bit handling of gas. So that will say it can also have up to 50% gas handling. And on the top of the right, you see the operating window between the 6 and the 10. That's the operating window, that's the ideal path where we have to run. On the left side, we have the downthrust side. When you see the downthrust side, you see also that the stage is going down. So that stage is not not floating anymore, it is pushed down because we're running on the left side. And on the right side, you see it goes up. It starts to fly a little bit, so it goes up. And that's very domestic if you run that. On the left side, it's not really a problem because the more force going down. What we use in the geothermal is a compression pump. So the compression pump is meaning that all the stages are fixed on the shaft. So you can also understand that the stages goes down and the force comes pushed down. If you see on the right side, you see the pump, you see the intake, and you see the seal section. And the other side, you see the bearing, and the bearing is taking all the force. So this bearing is also lubricated by the rotation. So you need to have also minimum rotation, otherwise you don't have good lubrication. But that's a little bit how it's simply set up. We have also the seal section, what I said. The seal section is handling the extraction and from the oil, so the oil is heating up. So the bags is extracting when it's heating up, and when it's cooling down, it goes in a little bit. We use always a tandem seal, because if you have a tandem seal, you have longer run life, and also you can handle more startups. This is a little bit the pumps we have in our portfolio. Let's say on the bigger size, of course, we have also smaller size, up to 30 cubes per hour. But this is a little bit the standard what we use in geothermal. So that's a little bit from what we use here in Taiwan, is 7-inch. You can 7-inch liner or casing. We can go up to 100 ton per hour. And with a 958 casing, you can go up to 200 tons per hour, or even 200 tons per hour. Well, otherwise, you need to go to 33.8 or bigger. And you see we have pumps up to 165 liters per second or 600 cubes per hour. This is how you see. This is an operating charge from the pump. You see again the yellow part is the operating window, and you have again left side is the ground side, and the green line is the efficiency line of the pump. But you see here also the pump efficiency is a little bit different from it's depending on the pump. And normal when the pump is bigger, your efficiency also goes up. Big pumps. Now a little bit about the permanent magnet motor, what we are promoting for as a Novomet. As per NEMA standard, every 10 degrees decrease, the run life goes up by twice. So that's a little bit what sometimes people forget. When the temperature goes up, all electronics don't like heat, but if you increase with 10 degrees, it goes up, life will never twice. And that's why a permanent magnet motor runs longer, because it is cooler. It's always more than 20 degrees cooler than a induction motor. Here, I hope that everybody a little bit knows what a motor, but the difference is between a permanent magnet motor and induction motor is that the permanent magnet motor is, the rotor is a magnet. Because it is a magnet, it has no slip. The induction motor is always a little bit slip. If you have 60 hertz and you want to run 3600, it not run 3600, 3400, 3450. So you have always a little bit slip, but you have also heat because you have more windings in your rotor. And that's all about the formula I squared R. skip this one. This is a test what is done in 2051 by a big oil company, and Novomet came as the best out of the test related to the motors, drive, and the total system. And also they saw the permanent magnet motor run 20 degrees cooler than an induction motor. So the motor lasts longer. Oh. So here you see a graph between again between the permanent magnet motor and an induction motor. The blue line is the induction motor, and you can see when the power or the load is only 30%, or let's say 100%, there you see a difference of 50% efficiency. But if the load is lower, you see the induction motor drops very rapidly. And if you don't need the power, let's say somewhere winter operating or whatever, then you can see the efficiency always high, with the permanent magnet motor is almost flat. Alright. Yeah, here you see our tandem motors, or our motors. You can see it can up to 250 C winding temperature, and that's a little bit depending on the load and how hot the motor is, and from there on we do the calculation. We have also designed a new seal or a new protector, what we call a new protector. There's no rubbers or something like that. That's all related to metal, and there is no rubbers anymore inside because of the high temperature. And we can use the pump on the left side for 600 cubes per hour. It's a picture from our successful in Turkey. In Turkey we are really successful. We have more than 90% market share in Turkey. The average water level on surface is 180 C. So you can imagine that the temperature is down quite high, or a little bit higher of course. And we have more than 150 pumps running there, very successful. And you see also an installation in Turkey. You see on the left side, you see the gauge on the motor. In the middle of the picture, you see the shield section, you see the protectorizers, you see the cable on the left side. In the right picture, you see a wellhead with our takeoff kit, where the cable comes out of the well. You see another installation we've done on 64, 5,000 cubes per day. Yeah, also with the 740. 740 is standing for 7.4 inch is the OD of the motor of the system. Yeah, this one we replaced. So this one is a replacement of the competitor, and we did calculation on how much power the competitor used, and the customer was not happy with the competitor, and they installed our pump, and we did calculation, and we reduced the power consumption up to 28%. This is the installation we did in Iceland, 2021. Another successful installation we did there. Also in Iceland, the water level was dropping, and we replaced this line shaft pump for an ESP. One point was the noise, and the other one was the head of the line shaft pump was not reachable anymore. But that was the reason that I wanted to outreach these. Still running. Another one in Iceland. Yeah, it's related to the installation time. We reduced the installation time up to 75% compared to the 9-jet pump. And also the flow rate goes up from 20 liters per second up to 40 liters per second with our Geyser PCB system. This was just a nice picture because the last installation we did last year in December, and we saw the northern light. I think okay, that's a nice picture. All right, thank you.